How you doing, everybody? Randy Richard in the shop. Today I'm going to do a little X-Carve project, and I'm going to show you how I made this engraving pen mount for the X-Carve. This fits right in the same mount that the DeWalt 611 mounts into. You just slide it out and you slide this engraving pen in this mount. So we're going to go and we're going to make this and get that done, and then in a future video I'll show it at work here. I need to design up a couple projects for it. So this is a Sioux air engraving pen, and I'll be shown in the video. So let's go make it.
Okay, here's the part for the engraving spindle mount into the X-Carve. What I did is I'm just going to take a chunk of aluminum here that's it's going to be 2.71 in diameter. We're going to make a couple cuts in it. We'll bore it out first. There's two bores. One end here is a little bit smaller, about 635. The other end's a 690. So when you slip it in, it will just fit real nice into the smaller end here. And then we're going to have a couple cuts in it. As you can see, that will form a spring action on this half here. And then we'll have a 1/4 socket head cap screw going down through here and for clamping. Now what we're going to do is we're going to slip this whole thing right into the mount where the DeWalt 611 is. I'm going to pull the DeWalt 611 out, slip this right in there, and clamp it in the same mount. This should work out quite well, I think. And let's see here. We'll change the view so you can see kind of a cutaway view of it. There you go. You can see how the holes go. You can see how the holes go through here. Counterboard, and the threaded part will be down here. And you can see the slots and cuts in it. We just use a slitting saw to cut those. And you can see the two bores on the inside, larger and smaller here. So that's what it's going to look like. We'll take it back to a nice shiny piece of aluminum. I don't know if it's going to be that shiny or not, but we'll try. But this should work out pretty good. Nice, it's nice and simple. Nice and simple. Alrighty, let's go.
Just here's the drawing. What we're going to be doing. I generated this from the 3D drawing I showed you, right from all within Inventor. They make it really quite easy after you make your 3D model to make an actual print drawing. So you get all your dimensions in there. Alright, this is a piece of 2 3/4 inch aluminum, and it's the one in roughly it should finish up about 1 7/8 in length when we're done. We're just going to get things we're going to face things off, get things kind of cut here, and we'll get our bores done. Yep, 2735. So we need to take off 25. Okay, we're going to try to do this in one cut. See what happens. We'll see how we did. I'd say that's perfect. Always, this is something to be observant of. Most inserts, I've always found that if you take a heavier cut, you actually come out more accurate than if you take a lighter cut. Now, unless you have an insert that is, specifically a finishing insert, maybe you can get away with a real light, 1 or 2 thousandths cut. But a lot of times, I will do that. I'll come up and take a 15 thousandth cut as my finish pass, and I'll be right on. So because the bit has a little bit more to grab, and it gets in the cut a little bit better, and it kind of depends on the material you're using too, and things like that. So just something to think about. My Don Cossett chamfer tool there, nice big chamfer. I'm using a 3/8 spotting drill here today. Got a 9/16 bit in there. We're just going to drill all the way through on this. Now I'm running a 5/8 bit in there. So I measure this, and I want 635, and after drilling with that 5/8 drill, it's 635. And what I want, this is the engraver, this knurl part, this is a straight section of this. This is where we're going to be clamping. And I measure this at 635, 634, a little under, but I still can't quite get that in there. So I'm going to chamfer that end and see if that will slip in. And then we'll see, maybe we have to just a skim cut bore it. We want that thing to be a nice slip fit. Yeah. So we'll just do a skim bore on that. Okay, I have a boring bar in there, and I'm just going to take off a whisker. I only need to go in there I only need to go in an inch. Okay, we'll do a test fit. Oh yeah, that's perfect. That's just hardly anything. Just sliding in. So we'll leave that. We're going to pull it out. We're going to put a forge on, and we're going to come back, grab the OD, and finish up the other end. And then we'll be ready to do the milling. And yes, this is the famous chuck from the Stand Bar Z chuck competition, and the face-off between Tom Lipton and Adam Booth. Sorry, Tom, but Adam kicked your butt on that one. And but this is the very chuck that was all done on, and I was honored to be able to supply a chuck for the competition. It was the Bar Z Bash was a super fun time. So I feel honored that the very Adam Booth and Mr. Tom Lipton have used my chuck. Plus lots of others. And the winner of the competition, Juan Rojas. So there it is. I had to make some soft jaws for the lathe. I did a little video on making these ones here. So these are my like 5-minute soft jaws. That's half a thousandths. We'll go with that. That'll work. See how we came out there. Barely feel anything at all. It really won't matter. It's more about how it, just as long as it fits in that spindle holder and is snug in there. I mean, you know, when you tighten it up, it's tight. 271.06. So that's within a 1/10 of what I measured on the other side. That's sweet. After that, we're going to bore this out to 690. That's what we would like, but I can't do it with that boring bar. It won't fit in there. I got a boring bar set up. I'm only going to go 850 deep. I've set it up with a dial indicator on the ways. And we need to take off it's about 60 thousandths, so 31 thousandths per side. So we'll do a skim, do a measure, and then get her cut. We need to take off 26 aside here, so we'll do a 15 and then we'll finish up with the rest. I think we're just gonna slip that in there. See, this bigger bore is not, this bigger bore on here is not really a straight bore. It's kind of curved and stuff. So that's why we need to have a clearance. Oh yeah, that's like beautiful fit. Oh yeah, that's like perfect. Sticks out about 3/4 of an inch on the other end, which is just fine. Could go a little deeper, I guess. Yeah. I'm going to peel that sticker off, and I think that's holding it up actually. Warning. Warning. Warning, Will Robinson. Warning. I avoided the warranty. Yeah, I think I'm going to leave it. I'm going to my plan, so I'm going to leave it. Okay, we're there. I'm going to pop that out. All right, we got my 6.5 inch slitting saw in there. I'm set up halfway through the piece, 1 inch down, and we're going to cuss that sucker off. Carbide tip. That was 1 inch 355 thousandths deep, and I don't know, 50-60 thousandths thick, running on not very fast, probably less than 100 RPM. It wasn't very fast, but cut it like butter. So here's a quick look at what we're going to do. So we got that slit all the way through, and that's halfway through, halfway through in this direction. So now we need to put a slit through there, and we're going to do that with a small slitting saw. And we need to put our holes in. Now this is tapped, threaded quarter 20, counterboard and stuff. Anyway, so what I did is I threw a ruler, scale, in the slot here and seated it down on the bottom, snug. And I'm running a dial indicator on the top here, so I can get my drilling square with the world here, square with the slot. And then I'll do the same thing for cutting this horizontal slot. So this worked out pretty good. I'm about within a thousandth over 2.5 inches or so. So I'm happy with that, and I'll get set up, and we'll go in here with a 3/8 end mill first, and then we'll do a drill with a 1/4 inch clearance, and we'll drill all the way down though with a 2.201 number 7 drill for the quarter 20. Okay, here we go. There's the piece. Oldie bird cleaned up. That's going to go right in there. And then we'll clamp it in here. I got a short screw in here now. I need to get a little longer one, but that clamps in there real nice. And I'm going to slip it up here in the X-Carve here. I don't know if you can see that there, and you can see I can adjust it a little bit. I have a little leeway. I can put it right tight or down a little bit, whatever I need. You stick it down a little bit, and then tighten up the. There we go. And that is basically rigged to ready to go. Now the end of this is a valve actually on the end, but that will be I'll just open that up. I'll probably put a valve on the air supply setup to control it. I think for now, probably we'll rig a solenoid valve in the future and have that on my control panel. And we'll rig another relay to control a solenoid valve, so it can go on and off automatically with the computer controlling it, this G code. Anyway, I think that's going to work absolutely phenomenal. I can't wait to give it a try here. So you got to draw up a project and give this a go. All right, you guys, we'll get a project here so we can test it out.